In this video cast, we'll look at three different portions of the vocabulary of chemistry, or sometimes known as the nomenclature of chemistry. Last time we looked at naming ionic compounds, which contain a metal and a nonmetal, or a polyatomic ion and a nonmetal, or two polyatomic ions. This video cast, we will take a look at molecular substances, a special type of molecular substance called an acid, and we'll also look at simple organic compounds. Make sure that you have your periodic table available, a list of polyatomic ions, pencil and paper out to write down notes during this video cast. Pause the video now if you don't have those things. Let's begin with molecular substances. Molecular substances are made of two nonmetals. The simple ones that we will name today contain only two nonmetals. There are no charges in molecular substances like we had in ionic substances. These two nonmetals stick together without charges like we have in ionic things. There's no drop and swap of the charges like we did in ionic substances. And they simply use prefixes to name how many of each of the nonmetals are in there. It's very important that you can distinguish the difference between metals and nonmetals on the periodic tables so you can separate a molecular substance from an ionic substance. So if you take a look at a periodic table like this one, for example, remember that this staircase right here separates the metals which are on this side of the periodic table. All these things, everything left of that staircase is a metal, from the nonmetals which are located over here. The nonmetals which are located over here. The only exception, remember, is hydrogen. Hydrogen is a nonmetal which belongs over here next to helium. And so when we name molecular things, we're really only naming things that contain elements from here on over. From here on over. Occasionally they'll contain a semi-metal like silicon or arsenic, but for the most part it will be only nonmetals over here on this side. Well, the prefixes you need to learn are mono for one, di for meaning two, tri meaning three, tetra meaning four, pent meaning five, hex 6, hept 7, oct 8, non 9, and dec 10. Pause now and write down these prefixes and the number of things that they mean. You'll need to memorize those prefixes. The only rule is that you never use mono on the first element. And some examples of these would be if we would have, for example, SO2, where there's one sulfur and two oxygens, both nonmetals, and I know that because they're both over here on this side of the periodic table. The first element I would not use mono on, so I would just simply call it sulfur. And the second element I'd use the prefix di on because there are two of them, so I'd call it dioxide. And I'd call this molecular compound sulfur dioxide. Let's look at some other examples using these prefixes to name them. For example, N2O5. Use the prefix di to name the first element. Dinitrogen. And then the second element, we'd use the prefix pent or penta if the second element does not start with a vowel. But since oxygen starts with a vowel, we just call it pentoxide. And notice that these molecular substances always end the second element with the ending IDE. Let's take a look at another example, P4O10. The prefix I'd use for phosphorus is meaning four is tetra, so I'd call it tetra. The name of the first element, phosphorus. And 10, which prefix is dec, so I'd call it tetraphosphorus. Dec and then the name of the element, which is oxygen, but remember I'd change it to IDE, so I'd call it oxide. Tetraphosphorus decoxide. Try this one now, CO2. Hopefully you did not use mono on the first element and you just called it carbon, and the second one you used the prefix di, meaning two, and then you used the ending IDE and you called it carbon dioxide, and you would be correct. Let's try going the opposite direction. This time let's pretend that we have the name and we need to write the formula. Carbon monoxide or carbon monoxide. The first element doesn't have a mono or any prefix in front of it, so we know there's just one. The second one has the prefix mono in it, so we know there's just one of them, and so we write carbon and oxygen. You could put a 1 down here and a 1 down here if you wanted, but remember, if there's no number written there, there's assumed there's one of them. Try this one, nitrogen trioxide. Since there's no prefix in front of the nitrogen, I just write N. Trioxide, the prefix tri means there's 3, and so it's NO3. Notice I don't worry about any charges. I don't look up anything on the periodic table. The only thing I need to know is that both nitrogen and oxygen are in the nonmetals area, and that's why they're named as molecular substances. The last one, diphosphorus pentoxide. See if you can do that one. Pause the video now. Phosphorus, diphosphorus would be P2. Pent means 5, so P2O5 would be diphosphorus pentoxide. That's how to name molecular substances. Let's go on to the second thing we're going to learn how to name today, and those are called acids. For our practical purposes right now, what we need to know in this class is that acids are substances that start with an H. They start with a hydrogen, and they're going to have an H and then some nonmetals. A nonmetal or more than one nonmetal attached to it. So for our purposes, an acid is an H, a hydrogen, and then some nonmetals. Now we'll learn in chapter 16 next year that there are many other acids that may or may not have hydrogen as the first element. But for our purposes, that's what we need to know. There are two different classes of acids that we're going to learn about today. One is called a binary type acid, and the second one is called an oxy acid. Binary acids consist of two kinds of elements. Two kinds, not just two atoms, but two kinds. One of them is an H, and the other one is a nonmetal. I'll just put X here, meaning some type of nonmetal, okay? Now, if you look on your periodic table, there really aren't that many choices of nonmetals. There's fluorine, chlorine, bromine, and iodine, sulfur, oxygen, nitrogen, phosphorus, maybe carbon, and maybe selenium. But other than that, everything else is a semi-metal or a metal over here. And those things can make binary acids depending on what their normal charge is. I'll always assume in an acid that the hydrogen has a positive 1 charge, like we did in naming or in putting together formulas for ionic compounds. Now technically acids don't fit together the same where we drop and swap charges, but we can use that idea. We can use that idea when we write formulas for acids. So for example, binary acids could be HF, HB, HCl, HI, or it could put it together with sulfur, and since sulfur is in group 16 and sulfur has a -2 charge, now I'd drop the 2 down here and I'd write it as H2S. Or I could have hydrogen and nitrogen come together, and since nitrogen is in group 15, I could see nitrogen right here in group 15 has a -3 charge. I could drop and swap that and I'd end up with H3N. These are binary acids. When you name binary acids, make sure to recognize that there's only two kinds of elements there. And then you put the prefix hydro on the front of the name. Then you put the stem in the middle from the element that's connected to the hydrogen, like for instance fluoro, chloro, iodo, nitro, sulfo or sulfuro. Okay, and then you put the ending ic at the end, ic, IC. So a binary acid always takes on the form of hydro something ic. And so in these cases, this would be called hydrofluoric acid. This would be called hydrochloric acid. This would be called hydrosulfuric acid. This would be called hydronitric acid. Notice they all started with the prefix hydro and ended with the suffix ic. It must be a binary acid with only two kinds of elements to be named with hydro at the beginning and ic at the end. Make sure you're very closely aware that this is hydro with a D, because we're going to encounter a stem or a prefix in the oxyacids that sounds very similar to hydro, but it does not have a D in it. It has a P in it. And the ending ic only occurs in binary acids with two kinds of elements. Oxyacids, on the other hand, contain oxygen as well as a hydrogen, which all acids that we're learning about today have, and another non-metal. Oxyacid examples would be things like HNO3 or H2SO4 or HClO3. Notice how they have hydrogen at the front, just like all acids do. They have some other non-metal in them, like nitrogen, sulfur, chlorine. They could contain fluorine, bromine, or iodine, or phosphorus as well. And then they have oxygen in them, and that's why they're called oxyacids, because they have oxygen in them. Now, to name oxyacids, you need to know your polyatomic ions. And if you lost or forgot your polyatomic ion page, remember this was printed in your handout where it said ions to memorize, and it gave a big list of polyatomic ions for you to know the name, formula, and charge of, and you'll have a bunch of quizzes on them too. And here are some selected ones with the formula and the charge and then the name of them as well. And there's more down here for you to know as well. Now, if you know the name of the polyatomic ion containing the oxygen atom, then you can easily decipher and figure out what the acid name will be. So make a little chart of polyatomic ion and acid, and we're going to make a list here of how they work. Okay? If the polyatomic ion name starts with the prefix hypo and ends with the ending ite, then the acid name will simply keep the prefix hypo, but the ending will change to us. If the polyatomic ion, and I should have written ion here, I don't know why I wrote atom, polyatomic ion. If the polyatomic ion simply ends in ite and has no prefix, then the acid name will simply change to the ending us. Notice there's no prefix on any of these unless there was a hypo prefix. If the polyatomic ion name ended in ate, then the acid name will change to ic. And if you remember your polyatomic ions that ended in ate always had one more oxygen than the polyatomic ion name ending in ite. Lastly, if the polyatomic ion name starts with per, or has the prefix per, and ends in ate, then the acid's name keeps the prefix per, but changes the ending name to ic. So notice the trend here. Hypo and per stay the same. Prefixes always stay the same. But the suffixes go from ite to us, and from ate to ick. So one way to remember this fairly easily is to remember he ate it and it was icky. I'll just put a dashed Y in here. He ate it and it was icky. And then somebody came along and was kind of 70-ish and said, dude, righteous. Notice, ite went to us. Now I put an R there just because it's kind of interesting to say righteous. But ate it and it was icky. And the guy says, ooh, dude, righteous, ite to us. So, ate goes to ite for the acid. Ate goes to ick for the acid, and ite goes to us for the acid. Well, let's look at a bunch of examples now that we kind of know the difference between binary and oxyacids, and we also know the prefix and suffix for binaries, and the prefix and the suffix changes for the acids. Okay? Examples. First one, H3P. Notice this is a binary acid. It only contains two kinds of elements, hydrogen and something else. Okay, when you do that, put the prefix hydro in the front, then put the stem of this element, which is phosphorus, phosphor, okay, and then put the ending ick on the end. So it's called hydrophosphoric acid. Always put the word acid at the end as well. If I forgot to say that before, remember that now. Okay, H2S. Let's take a look at that one. Well, that's a binary acid as well because it only contains two kinds of elements. Now, some people might be jumping up and down right now and say, this contains 3 hydrogens and a phosphorus. How can that be binary? That's 4 different atoms in there. Right, it is 4 different atoms. But remember, it's only 2 kinds of elements, hydrogen and phosphorus. Remember, it's 2 kinds of elements. Okay, so this one's binary as well, only H and sulfur. So put the prefix hydro on the front, put the stem for sulfur, hydrosulfur, and then put the ending ick at the end. So we call it hydrosulfuric acid. How about HBr? Oh, binary again. Okay. Hydro, brom, and then put the ending ick on the end. So we call that one hydrobromic acid. So those 3 are kind of fun. Hydrophosphoric, hydrosulfuric, and hydrobromic. Okay, next, this one, H2SO4, is an oxygen-containing acid. So we call it an oxy acid. Remember, for oxy acids, if the polyatomic ion ended in ate, we change it to ick. If it ended in ite, we change it to us. Ate it, and it was icky, righteous, ite to us. Okay, anyway, if you don't know your polyatomic ions yet, which you might not, or you might, you need to look up what SO4 is. And on this sheet, if I look fairly close here, SO4, I think is listed on here. There it is. SO4 minus 2. Sulfate. Oh, it ends in 8. Ate it and he was icky. Okay, so then I just changed the ending 8 to sulfur, not 8 anymore, not sulfate, but sulfuric acid, and that's what it is. It's sulfuric acid. I changed the name ending from 8 to ick. Ate it and it was icky. Okay, got that one down. Sulfuric, no prefix. No prefix, no prefix. So then I leave this ending the same. Okay, HNO2. Well, This one's an oxy acid as well. So I need to know what NO2 is and find out what its ending is. And NO2, I don't know if that one's on here or not. You have to have that one memorized or look it up on your polyatomic ion list and you'll find out that NO2 is called nitrite. Nitrite. I'll just write that down here. Nitrite. What does it end with? Oh, it ends in ite. Let's see. Ate it and it was icky. Oh, it doesn't end in ate. So if it's not ate, then it's got to be ite. Ite goes to us. Okay, righteous, right? Okay, so change it from ite to us, so I call it nitrous acid. Got it. Nitrous acid. Okay, good. HCl. Oxy acid again. Now ClO, is that on here? Oh yeah, as a matter of fact it is. ClO is right here. ClO minus 1 is called hypochlorite. Oh, it ends in IT. Ite, righteous. Ite to us. Okay, so keep the prefix. Hypo, chlor, and then change it to us, and then put the name acid at the end, hypochlorous acid. HBrO2, now I might not know what BrO2 is, but if I look at this schematic right here, notice what happened to the chloros. Okay, ClO was hypochlorite, ClO2 was chlorite, so now you could just replace bromine with the chlorine. So BrO2 wouldn't be called chloride, it'd be called bromite. Oh, bromite. Well, let's see. So I call it bromite, righteous. Okay, so I change it to us, bromous acid. All right. Now, what you also have to become good at is going backwards. So, cover up the formulas right now. Take a minute. Start backwards from up here and see if you can write the formula for each one of these. Pause the video now and see if you can do that. All right, last portion after you're done pausing is how to do some naming of some simple organic substances. Now, organic, remember, are living or once living things. That's kind of the definition of them. But it's a little broader than that nowadays, and when you go to college, you'll get a wonderful opportunity to take at least a year-long class in organic chemistry. The simple organics that we're going to learn to name today are carbon and hydrogen containing things, and some of them will contain oxygen. But for the most part, it'll just be carbon hydrogen containing things. The ones we're going to learn today are called alkanes, A-L-K-A-N-E-S. Alkanes take on the formula of C to the N, H to the 2N plus 2, and they always end with the ending A-N-E. Pretty cool. Alkanes, A-N-E, and in anes. C to the N, H to the 2N plus 2 means that whatever the number underneath carbon is, you put that number in right here, multiplied by 2, and add 2 more. So for example, let's say it was C2. Well, I'd put the number 2 in here, and it'd be 2 times 2, which is 4, plus 2 more is 6. So my number of hydrogens would be 6. These are called saturated hydrocarbons, actually, and we'll learn way more about these back in chapter 25 next year. And we'll shove in a little bit more about organics as we go along as well. Anyway, to name these, they're always named based upon how many carbons there are. And depending on the number of carbons, there is a prefix given to the name, and then the A-N-E ending is tacked onto it. Take a moment right now and write down these prefixes. For 1 carbon, the prefix used is meth. For 2, it's eth. For 3, it's prop. For 4, it's bute. 5, it's pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. 10 is dec. And from about here on down, it should look familiar. It's just the first 4. Meth, eth, prop, bute. That might look a little bit different. So if you're given something like C2H6 like we had, all you right up here, all you need to do is look at the prefix eth and then tack the ending ane on the end. So this is called ethane. Or let's say it's C4H10. Well, now all you have to do is look at what's the prefix for 4 carbons. Well, it's bute. And then put the ending ane. Hey, this is butane. I've heard of that stuff before. Yeah, it's the stuff inside of your lighters. Exactly right. Okay, but let's say you're given the name now. Let's say it's hexane. Ooh, that sounds like a cool chemical. Okay, well, anyway, hexane would mean that there are 6 carbons, and if I know it fits the formula C to the N, H to the 2N plus 2, that means my number of hydrogens is going to be 2 times 6, 12, plus 2 more, or 14, so C6H14. Difficult? Not too tough. One other group are called alcohols that we're going to learn about. Now, alcohols are a derivative of alkanes, and these contain an OH group, or a hydroxyl group, stuck onto the chain of carbons, okay? Now, they use the same prefixes for the number of carbons to name them, except they end with the suffix OL instead of ANE like we used up here. Now they have the suffix OL, or OL is how you say it. So, for example, let's say that we had the alcohol C2H5OH. Notice how it's got a hydroxyl group stuck onto it, and it still kind of fits the same format as the alkanes. Well, we'd use the prefix for 2 carbons, which is eth, and we'd call it, instead of ethane, we'd call it ethane, and you'd put OL at the end. Hey, I've heard of ethanol before. Yeah, it's the stuff that's in your gasoline. It's also the alcohol that's in liquor, wine, and beer. Okay, let's try another one. Let's say it's C4H9OH. Look for the prefix for 4 carbons. Wait a minute, what is that again? Oh, it's bute. Okay, so this would be called butane, not butane, but put an OL ending on it. It's called a butanol. Cool, interesting. Okay, let's say that you're given a name of an alcohol. Now, let's pretend that it's Octanol. Ooh, sounds like a dangerous substance. Octanol. Well, that means I'm going to have 8 carbons. How many hydrogens am I going to have? Well, it turns out to be C to the N, H to the 2N plus 2, the same, except you have to get rid of 1 hydrogen to put the OH on. So if it's 2N plus 2, it'd be 16, it'd be 18, but this time I'd put 17 on there and then tack the OH onto the end. This is naming alkanes and alcohols. Good luck with your nomenclature.